the sake of those who are not here, we looked at the first two simplifications. Simplify the following. We had this on board, the 37 through to that, and that gave us the solution. This was the solution. We got 16 as the answer, and then we moved again to this one, the second question. And this was the second question. You can see the second question here. And then this was the solution that we had. So if you have time, you can take your time and go back and watch it. At this juncture, I would want to move straight before I share the screen to introduce to you the man to handle us in this wonderful subject, mathematics. It's a long time I studied maths myself. He's a person I've known, and he's a mathematician. We have known each other for a long time. We've not met for almost about 17 years back, but we met 20 years ago in the same institution. And I can tell you that he's the right person for this subject. He's a mathematician. The PTC we know is a science and maths institution. Yes, we do have art students, but predominantly we are into maths and science. And he is known to be a mathematician right from college. And so having him here is an opportunity that the Lord has given us. He has vast exposure when it comes to teaching. He's still in the classroom. He's still in the classroom. And so for me, I know he has it. As I'm telling you, he completed the training college. And after the training college, he went to the University of Cape Coast to pursue his Bachelor of Science in Mathematics and Statistics. Again, he continued to do Master of Science again in Statistics. And again, he went again to do his MPhil in Mathematics Education. So people of God, I can say that for the past 17 years, he's been teaching mathematics. And he has had higher education, holds 2 masters in mathematics and statistics. As I'm telling you and talking to you at the moment, he has had several places where he's taught and he's made several contributions to the body of knowledge. At this juncture, I want to introduce to you our dear brother, who is a teacher and ready to give us what God has for us. Our brother George Benson Kakraba, a petition and an edicanfo, will take us through mathematics. My dear brother, you are most welcome to our meeting today.
Thank you so much, Reverend Doctor. I'm grateful for the privilege God has given me to share whatever we've learned over the years with his people. Please, can you make me the host so that I can share my slide before I will kickstart? Because I can't share the slide at the moment, please.
Yes, I've seen you are using a different. Yes. Yeah, please do. Please do now. Thank you.
Okay, thank you, Rev. Hey, I can see your face now. Thank you. You're looking great, sir.
Thank you.
Okay. Please, I hope you can see my slide on your screen.
Yes, please.
Okay, thank you so much. Let me also apologize sincerely for last week what happened. Only God knows. So I'm sure Reverend might have briefed you. So sorry about that. It wasn't planned. But thank God we are here today. Today to apologize. I didn't know the time has been rescheduled to 11 a.m. I thought it was still midday. So I was getting ready to come before I had the call that it's rather 11. So sorry about that. But by the grace of God, we are here. So we want to kickstart. My task for the next 7 weeks is to take us through some topics. As you can see on the screen, the scheme of work for the 7 weeks. Hopefully, we hope to touch on raw number operations this week. Then the next week will be on sets. The third week will be on algebraic expressions and simple linear equations. The fourth week will be on ratios and percentages. The fifth week will be on basic statistics. The sixth is logical reasoning and hopefully revision and solving of past questions. But basically, what I've been trying to do whilst I was trying to prepare my lesson was to go through the past questions and what past question is inside the one that was sent to me by Reverend Doctor. I picked some of them to put it in the presentation. So I'm hoping that even if you are not able to solve all the past questions, by the time we are done, we would have solved most of the past questions. I've already seen a trend that there has been repetitions in the past questions. So I'm sure even if you are not able to solve one, we solve majority. By the grace of God, we shall go through. I hope you cannot hear me, please.
Yeah.
Hey.
We can hear you.
Thank you. And please, before we carry on, let me share these two thoughts with you. The first has to do with repetition being the mother of all learning. A father in the Lord, Reverend Dr. Kisied, who is in the US, taught me this, that the best form of learning is repetition. So whatever you read over and over and over again, no matter what, it will stick. Then when it comes to mathematics, basically what helps us to do maths well is one, to understand the concept and also to understand the examples. And when you understand the examples, you can use the example.
Hello, Papa, are you okay? Is the network disturbing us?
You can hear.
Hello, Sir Benson. All right, I'm sure he would have to work on his network. Yeah, I'm sure he would have to work on his network. Yeah, unfortunately, we lost him. Yeah, so we would have to work on his network for some time now. That's the problem. Okay. Yeah, that's the problem. So what did you hear? What did you hear him tell you? Yeah.
Papa,
oh, tell me. If mine was on mute, so I didn't hear.
He said repetition is the mother of all learning.
Okay. That's fine. What else?
We need to understand the examples and then practice them and use the same concept in doing different things. And also he has realized that there was also a repetition of past questions. So maybe it will help us.
Hello.
Yes.
Sorry, there was a little drop. Sorry about that. So now I've connected the cable. Because of the time, I was just using the Wi-Fi straight away. So I've now connected the table, so I'm sure it will be good. All right, thank you. So please, I hope you got the 2 points I was trying to share with you. Hello.
Yes, Papa. Yes, Papa. Yeah.
Yeah, so please, I hope you got the 2 points that I was trying to share with you. Please, can you still see my screen?
Please share.
Okay, I'm sharing again. Please, is the screen back on?
Yeah.
Okay, thank you. So can we go now?
Yeah.
Okay, good. So please try and understand the examples for me. And please try and go over and try and practice before we meet again. Thank you so much. All right, with that said and done, please, we're going to look at our introduction to numbers. And basically, numbers are the building blocks of mathematics. Interestingly, our world is basically all about numbers. Church, everything we do is about numbers. Our mobile phone, you can identify, all of us have numbers that is identifying us. So now if I want to call any of you, I want to call Papa, I have to dial a number. So numbers is all over, we deal with them. But when it comes to mathematics, numbers are the basic building blocks of mathematics. Then when you talk about number, really, a number is a mathematical concept. So when you have a number, say, when I think of 2 in my mind, then we say it's a number. And when I write the symbol down, then we call it numeral, but most of the time we still call it as number, but the appropriate word is supposed to be numerals. So when 2 is in my mind, it's a number. When I write it down, then it becomes a numeral. But most of the time we still call it numbers. It doesn't matter, but basically it's supposed to be rather called numerals, but because of we not knowing, we still call them numbers. So when it's a mathematical idea or a concept in your mind, it's a number. When you use symbols to represent that idea or the count you are doing, then we have numerals. We call it numerals. And I'm sure you are familiar with the some aspects of the real number system. They include what we call the natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Broadly, we categorize them into rational and irrational numbers. These two make the real number system. So when we talk about the real number system, basically it's categorized as rational numbers and irrational numbers. Then another rational numbers, we can have the natural numbers, the whole numbers, the integers, and what have you. So when we take the natural numbers, for example, they are counting numbers that starts from 1 up to infinity. So example, as you can see on the screen, we have 1, 2, 3, and so on and so forth as example. Then for the whole numbers, they are also counting numbers, but the whole number, they start from 0. So the addition to the whole numbers is 0 to the counting numbers. So when you start counting numbers from 0, then we are talking about whole numbers. Then integers, normally we use Z to represent integers. N is used to represent natural numbers. W is used to represent whole numbers, and Z is used to represent integers. Then for the integers, it is both negative and positive counting numbers, including 0. So as you can see on your screen, for the set of integers, we started from negative infinity to positive infinity. And for example, we use -3, -2, -1, 0, 1, 2, 3. So any number from negative infinity to positive infinity, they are called integers. Then also we have the rational numbers. For the rational numbers, we are talking about any number that can be expressed as a quotient of the other. So if I express A over B, where B is not equal to 0, because when you divide by 0, to be undefined. So the denominator should never be 0. So apart from that, then A, B belongs to the set of integers. So any set of integers that you can divide over the other, then we call it a rational number. Then when we talk about the irrational numbers, technically, the technical definition for the irrational numbers is that they are non-terminating and non-recurring decimals. But for a basic understanding, when you take all the prime numbers, and we'll go to prime numbers shortly, they are all integers. All the prime numbers are non-terminating and non-recurring. You know, for our numbers, we use a lot of approximations. So, for instance, I want to key a number on your calculator. For instance, I want to key √2. Because the calculator is 10-digit number, you see the number being displayed up to 10, but it is more than actually that number that is being displayed. But because it has been approximated by the calculator, you see only 10. So to get a basic understanding of the irrational numbers, we're looking at you're taking the square roots of the prime numbers. To refresh our memory on prime numbers are whole numbers that are greater than 1, and that can be divided by only 1 and itself. So any number that is greater than 1, that only 1 and itself can divide, we are saying it's a prime number. So for example, you take 2 can be divided by only 1 and 2. Then 3 can be divided by only 1 and 3, and so on and so forth. So 2, 5, 7, then we go to 11. So any number within the real number system, that's any counting number that can only be divided by 1 and itself, we are saying they are prime numbers. And we also want to look at fraction. When we talk about a fraction is a part of a whole, basically. So normally common fractions are expressed as using 2 whole numbers. So as you can see in my example, when I write 3 out of 5, we are saying that we have a whole that has been divided into 5 parts. So when I take out 3, then I represent it as 3 out of 5. So basically, a fraction is part of a whole. Please, as I'm going on, if anybody has an issue and anybody wants any explanation, probably can raise your hand. And when I'm prompted, I'll pause for any question. And certainly, when I'm done, the slides will be shared on the page for anybody to use for revision. I hope you are with me, please. Hello. Hello.
Hello.
Yes, we are with you.
Thank you.
We are here because we meet ourselves.
Yeah, we are with you, listening.
Okay, thank you. And please let me quickly say this. I wanted to say this. Last week, when I had a challenge, fortunately, Papa connected me to the English lesson. So I slept for about an hour, and when I woke up, Papa sent me the link. And I heard somebody was doing it in the car, and I was quite impressed. I didn't know the person, but I really wanted to commend the person. It's really the way to go in the 21st century. So thumbs up, whoever it was who was connecting in the vehicle while the English lesson was going on last week. Okay,
Kingsley.
thank you.
Kingsley.
So, Kingsley, okay. Kingsley, thumbs up if you are online today. Okay, thank you. These are examples of
I'm very
fraction.
much online, Papa. Thank you.
Thank you too. So these are examples of fraction. So 3 out of 5, 1 out of 3, 5 out of 13, and so on and so forth. Then we want to look at a proper fraction. When we say a proper fraction, basically we're looking at a fraction that the numerator, that's the top number, is smaller than the denominator. That's what it's supposed to be, because for instance, if I'm dividing an orange to 4 parts and I'm taking 1, then the proper fraction is that when I take 1, the rest, the denominator, that's the whole, should be bigger than the fraction that I've taken. And the fraction can be a maximum be equal to the whole. So if I divide an orange into 4 parts, there is no way I can take 5 parts out of it. But of course, because of our calculation, there are times we don't get what is supposed to be the norm. But for a proper fraction, it is a fraction that the numerator is smaller than the denominator. That's the bigger number. That's the top number is smaller than the denominator. That's the smaller, the bottom number. Then that will lead us to improper fraction. When we talk about improper fraction, it is also a situation whereby the denominator is smaller than the numerator, or in this case, the numerator is bigger than the denominator. So for example of the improper fraction, as you can see on the screen, when you have 5/3, you can see that 5 is bigger than 3, which shouldn't have been the case normally. So we are calling this type of fraction as improper. So as you can see in the case of the example on the screen, it was 1/2 or 2/5, and you can see that the numerator was smaller than the denominator, but in this case, the numerator is bigger than the denominator. So we are saying that when you see such a fraction, we call such a fraction as improper fraction. Then we have what we call mixed fractions. And when we're talking about mixed fraction, basically we're talking about a fraction that is a combination of a whole number and a fraction. A combination of a whole number and a fraction. So as you can see on the screen, the first example, we can see 2 whole number 3/5. 2 whole number 3/5. So when you see an example like this, then we call this type of fraction as a mixed fraction. Some also call it mixed number, but in terms of fraction, it's basically called mixed fraction. Then I want us to know that when we are solving math problems and the math problems involve mixed fraction, before you proceed with any further solution, you have to convert the mixed fraction into an improper fraction before you try to solve any mathematical problem that involves mixed fraction. So for us to see how we do the conversion, this is how we do it. You take the denominator and you multiply to the whole number and you add to the numerator. So as you can see, I've written 2 whole number 3/5 is equal to 5 times 2 plus 3. 5 times 2 plus 3. So the 2, which is the denominator, will multiply the whole number, and we will add the numerator. So as you can see, when we want to convert this mixed fraction, that's 2 whole number 3/5 to improper fraction, we will get 13/5, 13/5. And the second example to the same thing, we have 5 whole number 2/3. And that one, to you multiply the denominator, that's 3, to the whole number, that's 5, and add the 2. And that would be 3 times 5, that is 15, plus 2, that would be 17. So as you can see, 5 whole number 2/3, when we convert to improper fraction, we get 17/3. Hello? I hope you are there, please.
Yeah, we are here.
Okay.
But
And please,
just there.
and please, please, what you need to also know is that when you are solving problems, okay, and it involves mixed fraction, when you convert to improper fraction and you solve, and so the final answer is giving you a mixed fraction, you should convert it back to mixed fraction. I don't know your marking scheme, but with my experience as a WAEC examiner, normally when we give questions for especially the school candidates, for the NOVDEC, those who are writing remedial, WAEC seems to be considering them more, but for the school candidates, they don't consider them that much. But for the WAEC, when you don't convert your improper fraction to mixed fraction, they will not mark the final answer. So for instance, if it's 4/5 marks, you will get 5/5 marks, you'll get, say, 4/5 or 3/5, depending on what the marking scheme will detect. So please, when you solve and your final fraction is an improper fraction, you have to convert it to mixed fraction. What you do is that you take the denominator, like for instance, if you want to convert our 17/3 back to mixed fraction, you will divide the 17 by 3. We know that 3 goes into 17 5 times. So you have the 5 here. Then you can see the remainder. The remainder is 2/3. So that's how we convert. So the 15, when the 3 goes into the 17 5, you see that it will be left with 2. So we write 5 whole number 2/3. Okay, so let's take a look at addition and subtraction of fractions. Basically, fractions can be added or subtracted directly if they have the same denominator. The emphasis is that fractions can be added or subtracted directly. So that means that if I am given any two or more fractions to add or subtract, the first I need to do is to check the denominator, whether the denominators are the same or not. If they are the same, then I can add the numerator straight away. If they are not, then I have to make sure we get the same numerator. So we want to take an example, then we see how to approach it. So when we look at the first example, I have 1/5 plus 3/5. When I check, the denominators are 5, 5. So the denominators are the same. So we can simply add the numerator. So you can see that 1/5 plus 3/5 is equal to 1 plus 3 all over 5, which will give us 4/5. So because the denominators are the same, that is 5, 5, we simply add the numerators. Then when you look at the B, you can see 2 whole number, 1/2 plus 1 whole number, 2/5. And like I just said a while ago, we first have to, because it's a mixed fraction, we first have to convert to an improper fraction. So what we do is that we take the 2 and multiply to the 4, the 2, and that will give us 4. And we add 1 to it, that will give us 5. And so when we come to the second one, we will take the 1 and multiply to the 5. 5 times 1 will give us 5 plus 2 will give us 7. So the first one, 2 whole number 1/2, sorry, will give us 5/2. Then the second one, 1 whole number 2/5 will give us 7/5. Then now when we check the denominator, they are not the same. So what we do is that we look for what we call the LCM, the least common multiple. And when we're talking now about the least common multiple, if you could remember, we look at our times table. So if we take the 2 and the 5, look at our times table. Then when we take our times table, we look at the multiples of 2 and the multiples of 5. The first number that would be the same is what we call our least common multiple. So for instance, when we take the 2 times number, you can see that when you look at the 2 and 2, the times table, 2, 5 will give us 10. So when you look at the 5 times 2 also give us 10. But if you want, you don't want to be bothered with the LCM, you can simply multiply the 2 times 5. That will give you 10. And there are cases that it will be more than the LCM, but when you still work it, you will still get your answer. So for instance, if you're not sure of the least common multiple, then we can have. The truth is that I was telling Reverend Doctor that because we are having only 7 weeks to go, I couldn't go to every angle, because if I go to every angle, we can't finish within the 7 weeks. Even today, the introduction to the numbers, I had to leave some of the topics out, some of the little aspects out, because I was looking at the past question that they just sent me. So I had to leave some of them out. So if not, you would have seen me going through all that I'm talking about. But because of the shortness of the time, I was trying to let it focus more on the past questions. So the concept that would derive the past questions, we were looking at that one. So I hope that you move with me.
Okay.
I hope I'm okay. Yeah, so to proceed, but when we get up to the C, if you have any, if it's not clear, please let me know. Then we take our time and go. And please, whilst I'm speaking, please be making some of the notes down so that it could be added to the slide that I will share with you after I am done. Okay, thank you. So when that is done, then we know that now our common denominator is going to be 10. So what we do is that I will take the 2, which is the first one, that's the 5/2. The 2 will go into 10 5 times. Then I will multiply the 5 to the numerator, which is the 10, which is 5. So please, what I'm saying is that for the first fraction, that's 5/2. The 5 will go into the denominator. The denominator we're having, the 10, it will go into it 5 times. The 2 will go into the 10 5 times. And the 5 that we get to multiply to the numerator, which is 5, which will give us 25. That's why you can see 25 as the first value there. Then when we go to the next one, I will take the 5. Then the 5 will go into the 10 2 times. Then I'll multiply the 2 to the 7, which will give me 14. That's why we are seeing 25 plus 14/10 there. Then if we are okay with that, then what will basically happen is that it will be equal to, when you do the sum, it will be equal to 39/10. It will be equal to 39/10. And like I told you, when you look at this, it's an improper fraction. So because it's an improper fraction, we have to convert it back to a mixed fraction. So what do? We let 10 divide in 39, and 10 goes into 39 3. 3 times 10 will give us 30. But it didn't go into it wholly. There was a remainder. The remainder is 9. So this will give us 3 whole number, 9/10. It simply means that 10 divides 39 3 times with a remainder of 10. Sorry, a remainder of 9. So we're going to have 3 whole number, 9/10. Please, are you okay with the example B, because it's not a common denominator?
Yes.
Please, are you all
Yes.
okay?
Yes, Papa.
Okay, thank you. I don't know how your exams rules are, but there are some of them, they might allow you to use calculator. I'm sure they allow you to use calculator. So for instance, the marking scheme, if they see us on the screen, they will not have any. So let's go on. When we get to the revision, we will look at those things. Thank you. So when we look at the C2, we are having 9/10 minus 4/10. Because the C, the denominators are the same, simply we are going to subtract the numerators. So as you can see, it is going to be equal to 9 minus 4 all over 10. And that will give us 5/10. And 5/10, we can see that the 5 can divide the 2. So now we let the 5 divide the 2, and it will be equal to 1/2. Please, are you okay with the 3 examples I've shown?
Yeah, the last one is fine. Hello, yeah, we are here.
So please, are you okay with the A, B, and C?
Maybe we can go over B again.
Thank you, dear. Please don't look at the B, okay? Please, I hope you are okay with the conversion of the mixed fraction to improper fraction.
Yes.
Yeah.
Good. Then, if that is okay, then please take a look at the, you see, we have 5/2 plus 7/2. Are you with me?
Yeah. Yes.
Good. You see, the denominators are not the same, so we cannot add straight away. So it means that we have to look for a common denominator. And I said that for a common denominator, what we do is that we look for the least common multiple.
Yeah.
It's okay. But even if you have forgotten about your least common multiple, it's simply you multiply the 2 denominators, because it still give you the same answer anyway.
Okay.
So when you multiply, in this case, we are fortunate that it's still the same LCM, but there are some numbers, it will be more than the LCM, but it wouldn't matter. It will still give us the same answer. Is that okay? Good. So now we multiply. Let's assume that we didn't even know our LCM. So we multiply our 2 to 5 to give us 10. Is that okay?
Yeah.
Good. Then now we take the first fraction. That's the 5/2. The 2 will go into the 10 5 times. Is that okay?
Yeah.
Then we multiply the 5 to the 5, which is the numerator, the 5 up there.
Yeah.
And then it will give us 25.
25. Yeah.
Good. Then when we go to the second fraction, it is 7 out of 5. Are you okay?
Yes.
So take the 5. The 5 goes into 10 2 times.
Yeah.
And as for this one, you can simply do with your calculator. That one, even if they say don't use calculator, they wouldn't know that you keep calculator. Then the 2 will multiply the 7, and that will give us 14.
14. Okay.
Good. So please, what happens is that when we find the LCM, or we simply multiply the two denominators, we take the first denominator and it goes to the common denominator, and whatever value we get, we multiply to the numerator. Then we take the second denominator, it goes into the common denominator, and whatever value we get, we multiply to its corresponding numerator. Are you with me?
Yeah. Yeah.
Then the rest is just to sum. So when we add 25 to 14, we will get 39.
Yeah.
And 39 out of 10 will give us good. Like I was telling you, I don't know who marks your exams, but for this, if it was WAEC wouldn't accept 39 over 10 as the final answer. They will penalize students by taking 1 mark. So that's why I was converting to a mixed fraction, because that is the norm. But maybe because it's a church, maybe they might overlook. I don't know. That's why, but I don't want to take time. That's why I'm letting you know. Are you with me?
Okay. Yeah.
Yes, thank you. So if we are okay, let me know, because you can see that there is one for you to try. Please, are you okay?
Yeah, Papa, yes, let's go. It's good.
Good. So please, how many minutes do I give to you to try the one that you can see on your screen?
Yeah, try. Okay, we have 4, 2 over.
So you try. Let's take about 5 minutes to try. Do you have calculators with you?
No, now.
Okay, but this one I'm sure you can. You try. Let me keep quiet and you try your hands on it and let's see how it goes. Oh my God.
This one will need calculators. This one will go here.
Please, can we have the questions on the screen?
You are on mute, sir.
Sir Benson, you are on mute. We can't hear you.
Sir Benson, can you unmute yourself, please? We can't hear you.
Sir Benson, you are on mute.
Can you unmute yourself?
Hello. Sorry. Hello. Yeah, please, are we done? Hello.
We almost finished. We are on it.
Okay, I even leaked the answers. So I don't know whether somebody saw it.
Where did it? Oh, I said that. Yeah. So 5, 4, 20. Oh, 70.
Are we done?
A little bit.
Yes.
I'm sure if our calculators were with us, we would have been a bit faster. But don't worry. Basically, what is important to me is the understanding. So I'm not bothered if you take the time because you have to understand. That's why I say you take your time and study the example. You get the example to help you solve what you don't know. So the understanding is what is important to me now. So don't worry, I'm here waiting. I see.
This one go here. 4, 4, 3. 12.
Meantime, please, that means that next week my time will be 11 o'clock, right?
Mm-hmm.
Yes.
Okay. Well noted. So I promise that it will not happen again like it happened today because I didn't know it was 11. I thought it was 12 o'clock. So it's been well noted now.
Okay, Papa.
Yes,
Finished.
please. Okay, can we compare our answers to this one? Then we see if we all had these answers. If not, then we have to look at why we didn't get it. Either the answers are wrong or we are
Correct.
wrong. Are you all getting these answers?
Yes, I got all.
Wow, we thank God.
I got all.
Okay, we thank God. All right, so can we put this now? Please, did we all get it? Or somebody is having a challenge.
Could you please solve the B?
The B.
Yes.
That's okay. All right, so can we all solve the B together? What are we supposed to do first? We are supposed to convert to, we are subtraction, so please, you know it's supposed to be 6 whole number 3/4, right?
Yes.
Minus 4 whole number 1/3, right?
Yes.
Good. Then please let's convert this thing together. So 4 times 6 will give us what?
24.
24.
Good. Then plus 3.
27.
So 27 over what?
7. 4. Yeah.
Yes, the denominator is 4. 24, please. Then minus, we go to the second one, please. 3 times 4 will give us what?
12.
24.
12,
3,
good.
4, 12.
Then plus 1,
13.
plus 1, 13. So it
Yes.
will be 13 out of 3.
3. Yeah.
Then you see that we don't have the same denominators.
So when you
Is that okay? So we simply multiply them and we are having what? 12.
12.
And the great idea about multiplying is that you know that it means that when I multiply 3 by 4 and I get 12, I know the 4 will go into 12, 3, and the 3 will go into 12, 4.
Yeah.
That's why I was telling you that we are having a challenge with even the LCM, simply multiply the denominator. And you get the answer. Good. So please now, 4 goes into 12, that would be 3 times, right?
Yes.
Yeah.
Then we multiply our 3 to the 27.
7.
So can we do that multiplication?
It is 81.
Thank you, 81. Good. So now we go to the next fraction. 3 goes into 12.
4.
4.
Oh, good. So and 4 times the 13.
52.
52. Is that right?
Yes.
Good. So now please, we're going to do 81 minus 52.
Yes. And it's 29.
29. Okay. And out of what? 12.
12.
Good. So 12 will go into 29 how many times?
2 remainder 5.
Good. So it will be 2 whole number 5 out of 12. And we are there.
Thank you.
Okay. So are we okay now?
Yes.
So we can proceed, right?
Yeah, but the confusion aspect is that if you subtract from, if you are not careful, you make the first number first, but always you subtract the first number from the last number.
Yes, please. So please, I intentionally picked it because I know they can trick you with it.
Yes.
They used to tell us in school that understanding the question is part of the exam.
Yes.
So I intentionally put it there actually. This was deliberate actually, to draw attention. So I'm grateful this class came up. Well, that was a deliberate thing to do. All right, thank you. So I'm sure that the challenge came from that. All right, thank you. So we want to look at now multiplication and division of fractions. Then now for the multiplication and division of fractions, basically to multiply fractions, we want to first look at multiplication. We multiply numerator to numerator and denominator to denominator. Please are you with me? So even if I am giving, say, 3 fractions, what I'm going to do is that I'll multiply all the numerators together and I'll multiply all the denominators together. That is basically what we do when it comes to multiplication of fractions. Is that okay? So as you can see, my example, I have 4/3 times 4/5 times 2/3. Is that okay? So it's simply going to be, for the numerator, it's going to be 3 times 4 times 2 all over 4 times 5 times 3. Is that okay? But you can see that we have some common denominators, common factors in the numerator and denominator. When you have them like this, they will cancel out.
Yes.
Is that okay? So the 4 will cancel, the 4 in the denominator will cancel the 4 in the numerator. Then the 3 in the numerator will cancel the 3 in the denominator. So if you left with 2 out of 5.
2 over 5.
Because if you multiply it straight, the reason why I did it like that, if you multiply it straight, you still have to convert to the basic fraction.
Lowest, yeah.
So why do you give us ourselves work? I multiply 3 to 4, I get 12. I multiply, I get 24. Then 5, 20, I get 60. Then 24 over 60. If I'm not careful, I miss it and I get the fraction. Then I'll get my answer wrong. Meanwhile, I want to do this. Nobody will penalize you because that is the way to do.
Okay.
Please, are you okay?
Yeah.
Good. And the B, you can see that I've also intentionally brought off 2. 1 whole number 2 over 3 of 8. Please, when you see off in any mathematics question, it simply means multiplication. Are you okay?
Yes.
Yeah.
Good. So it means that we are supposed to do 1 whole number 2 over 3 times 3 over 8. So like I told you in the beginning, because we are seeing a mixed fraction, what is the first thing to do?
You multiply the 3 by
We
1.
convert to improper fraction.
Convert it.
Good, good. So we're going to multiply the 3 to 1, and that will give us 3. Then we add the 2, that will give us what? 5. So we're going to have 5 out of 3 times 3 out of 8. And like you see, so it's going to be 5 times 3 over 3 times 8. And again, we can see 3 and we can see 3. 3 in the numerator, 3 in the denominator. So they will cancel out. So we'll be left with 5 out of 8. Are you okay?
And go slow on this part.
Sorry, oh, sorry. I'm sorry about that, my dear.
It's okay.
Please, should I go over?
Yeah.
Thank you, dear. Please, are you okay with the conversion of the mixed fraction?
Yes, sir.
Thank you, dear. So it's going to be 5 over 3 times 3 over 5. You're okay with that one?
Yes.
So you can see in the next place, I have equals 5 times 3 over 3 times 8.
Yeah. Okay.
I have 3 in the numerator and 3 in the denominator. So the 3's will cancel out.
Okay.
So it will actually be left with 1, 1, but 1 times 5 will be 5.
5.
So the final answer is going to be 5 out of 8.
Over 8. 5
yes, please.
8. Okay.
Yeah. So to divide, we will take some example that will be involving multiplication and division, because that's where we are going to. We are actually trying to get to where I saw Papa was with you, when Papa was holding the fort. We'll get the order of operation. Yeah, so when it comes to division of fraction, what we normally do is that the one that is going to divide, please are you with me? You invert it. When we're talking about invert, that means you turn it upside down. So the denominator will become the numerator, and the numerator becomes the denominator. Are you okay? Please, are you with me?
Yeah.
Yeah.
Then you multiply. So you simply turn the fraction dividing upside down, then you multiply it. Hello.
Hi, we are here.
Please, you get the concept. I want you to get the concept before we look at the example. So please, you get the concept. Hello.
Hello, Daddy. Yeah.
Please, is the concept clear?
Yeah.
Good. So let's look at the example. I'm sure the example will bring it out clearer. Thank you. So please look at it. We have 3 over 5 divided by 1 whole number 1 over 3. Is that okay? So because we are having a mixed fraction, still our principle holds. So we first convert the mixed fraction to improper fraction. So we will work on that before we come to even look at our problem. like I gave in the note above. So we are going to multiply 3 to 1, and it will give us 3, then plus 1, and it's going to give us 4. Is that okay?
Yeah. 4
then
over 3.
We get 4 over 3.
3.
Just a minute. So when you get the 4 over 3,
yes, Sir Benson, can we please wrap up in the next 13 minutes? Sorry about that.
No problem, sir. I hear you.
Thank you.
So when we have that, so we are going to multiply the 3 over 5 divided by 4 over, we're going to divide now. So we are going to invert. Please, are you with me? So
Yeah.
look at it, we have 3 over 5. Now it was 4 over 3. So we are going to turn it upside down. So you can see that now it is becoming 3 over 4.
Yeah.
Good. So 3 over 4. Then now the 3 is going to multiply the 3. And the 5 is going to multiply the 4.
4.
Good.
Okay.
So,
Excuse me, Sir Benson.
There is a little mistake. I just seen it. Yeah. So let me quickly correct that. Yeah. So it's going to be 3 times 3. Is that okay? Then that will give us 9 out of 20. So I just saw it. Sorry about that.
Okay.
So let me correct it right away. I'll correct it then. Please, let's carry on because of the time that I've been prompted. So I'll correct it before I forward them to you. Thank you.
Okay.
Okay, so with that done, I had wanted us to look at some applications, and I have application of fractions before we go to that. I have 2 quick examples. One is my own example, and then I'll pick the other from your past questions. So application of fractions. So the first example we want to look at is that a boy went to a supermarket and he spends 2/5 of his pocket money on biscuits, 1/4 on plantain chips, and the remainder on drinks. What fraction did he spend on drinks? Good. So to look at this question, please, all of you take a look at the question and please read the question for a minute so that you can get the concept of the question. Please, have you gotten the question?
Yeah.
Thank you. So to solve this question, we have been given 2 fractions that he spent. We said the question said he spent 2/5 of his pocket money on biscuits and 1/4 on plantain chips, and the remainder was on drinks. And we've been asked to find the fraction that he spent on drinks. So what we're going to do is that we are going to find the fraction that he spent on food, i.e. the biscuit and the plantain chips. Is that okay? So it's going to be 2 out of 5 plus 1 out of 4. Please, are you with me? Good. Then what is going to happen is that, like I told you, this time round, I was trying to, because it was application, because I was trying to show the process. So we multiply the 2 denominators. So you can see that I've done 4 times 5, and that'll bring me to my 20. Is that okay? Then the 4 goes into the 20. Sorry, the 5 goes into 20 4 times.
4, yeah.
That's why you can see I'm doing 4 times 2 up there. Then, and when I go to the second one, the 4 will go into 20 5 times. So you can see 5 times 1.
Okay.
And that will be equal to 8 plus 5 over 20. And this is equal to 13 out of 20. Yes, I intentionally wanted this to come because I've seen a past question exactly like this one. So I didn't have anything to go over. So now, when we get the fraction that is spent on biscuit and cheese, which we are now calling food, then what we do is that for all fractions, the sum of all fractions will be equal to 1. So the whole amount of the pocket money, when you sum all of the fractions of the money, will be equal to 1, as you can see written on the screen. So what we're going to do is that we're going to subtract the 13 out of 20 from 1. And that will be the fraction is spent on drinks.
Okay.
Good. So as you can see, so therefore fraction spent on drinks will be equal to 1 minus 13 out of 20. And for us to get a better understanding, I intentionally made the 1 to be over 1 because it is going to be a fraction that we are going to subtract. So any whole number that is the same as that whole number divided by 1. So for instance, if I have 2 minus 13 over 2, it's going to be 2 over 1. We're going to divide any whole number by 1, you're getting the whole number back. I wanted it for the purpose of the common denominator. So you can see that we have 1 over 1 minus 13 over 20. Is that okay? And that will be equal to, when you take the, like in the first case, so you're going to multiply the 1 to the 20, it's going to get 20. And 1 goes into 20 times. And 20 times 1 will be 20. Then 20 goes into 21, and that times 13 will be, 1 times 13 will be 13. So as you can see on the screen, we're going to have 20 minus 13 all over 20, and that's going to give us 7 over 20. Please, are you okay? Please, is this okay?
Yes.
Yeah. Thank you. So as you can see, I don't know if you have gone through the past questions. I'm sure you'll be familiar with this question that you can see on the screen now. Has anybody seen this question, please? Hello?
Yes.
Okay, good. So I'll crave your indulgence to that, please. Now that we've started, please be going through the past question that you gave me. Is that okay? All right. So with that too, we've been told that 1/3 of employees at Trinity Seminary drive to work, 2/5 come by bus, and the rest walk. Find the fraction of those who walk. So like we did in the first case, we are going to find the fraction of employees who drive and those who take bus, because these are the two that have been given to us. Is that okay? So we're going to have 1 out of 3 plus 2 out of 5. Is that okay? And because the denominators are not the same, we are going to have multiply them, and we're going to have 3 times 5. That's going to give us what? 15.
15.
Good. And now 3 goes into 15, 5. So 5 times the 1 for the first fraction will be 5 times 1. Then the second one, 2 will go into the 15 3 times. So we multiply it to the 2, which is the numerator of the second fraction. So you're going to have 5 times 1 plus 3 times 2. And the 5 times 1 will give us 5, and the 3 times 2 will give us 6. So you're going to have 5 plus 6 all over 15. And that will give us 11 over 15. Is that okay? So now we go to our main question. Now we want to look at the fraction of employees who work. It will be the fraction of those who don't work being subtracted from 1. So you're going to have 1 minus 11 out of 15. Is that okay? So in this, like the same way, it's going to be 1 over 1 minus 11 over 15. And like the same way, the LCM or the common denominator, we multiply 1 to the 15, you're going to have 15. So 1 will go into the 15, 15 times. So 1 times 15 will be 15. That's why we are seeing 15 up there. Then the 15 will go into the 15 1 time. So 1 times 11 will be 11. So you're going to have finally 15 minus 11, which is going to be equal to 4 out of 15. So for this specific question that was given, the final answer is supposed to be 4 out of 15. Is that okay? And I'm sure my time is almost up now because Papa prompted me that I have just about 15 minutes to go. So this was supposed for you to try, but because I'll leave the slides with you, I will leave it there. Papa, if you are there, can I? Hello, Papa.
Yes, please, I'm here.
Please, it's my time finally up. How many minutes more do I have?
3 minutes.
3 minutes. Thank you, Papa.
Yes. So please, you can give us the assignment. You can give us. Please give us more assignment to try.
I'll do so.
We like.
I'll do so. So I'll skip this one. Well, when I went through your past question, that's the only example I saw. That's why I see only this one. If not, I would have brought other ones. So, Papa, let's leave it here because I was supposed to go to compare and ordering fraction because I saw some examples too there. So I needed to branch to comparing and ordering fraction, but because it's 3 minutes, I want to leave it here now. So Papa and the rest, can you help me? What do we do now? The rest of the lesson that was not covered, do I come and continue before we go to the sets?
Next week, God willing.
Okay.
Yes, next week we'll come at the right time, and I'm sure
yes,
we'll be able to. So what we have done, if we're able to pick sample questions, if you're able to within the week, if you have any sample questions, you can place it on the board, and we'll try. The ability to form the equation from the sentence is what we need to get now. Once we grab that, we are done. Sure.
Okay, Papa. Okay. So I'll do so. There will be more examples. Just when I went through the past questions, that's the only example that I saw. So I'll pick my own examples and bring it on the page. Now that I've been put on the page.
That's right.
So let me thank everybody, and I pray that by God's grace, next week we'll meet here at 11 o'clock and we'll continue from here. I'm grateful for the opportunity. Thank you so much.
Thank you too.
Thank you very much.
God bless you, class.
And Papa, excuse me, before I leave, please, we are a church, so I can comfortably say this. Please, let's always pray before we study, and let's always pray before we write exams. It's very important. We need God in everything we do.
Thank you.
Thank you too. I'm grateful. So I'll be leaving for now. I'm so